Hi, my name is Todd McAlery. This video describes my PhD thesis research in the Department of Chemistry at the University of Waterloo for the Ontario Centres of Excellence Discovery Conference 2012. My research was conducted to reduce the cost and improve the quality of data collected to evaluate concentrations of toxic vapors in indoor air for buildings near contaminated soil or groundwater. This is a big issue during urban renewal, where residential properties are constructed on former industrial land. Volatile organic compounds like gasoline and solvents can pose unacceptable risks to human health through subsurface vapor intrusion to indoor air. As a result, indoor air sampling is a large marketplace. Indoor air and soil gas samples are currently collected most often into evacuated steel canisters. An alternative is to use passive samplers, of which there are several types. Passive samplers have several benefits over conventional sampling methods, but a rigorous comparison was needed to help understand their capabilities and limitations and support acceptance by regulatory agencies. I assembled a team of the world's best scientists in the field of passive sampling and was awarded funding by the United States Department of Defense, the U.S. Navy, and the Ontario Ministry of the Environment. Our testing included laboratory experiments under controlled conditions, field sampling at 5 U.S. military bases, and statistical analysis of the results. The data show that passive samplers correlate very well with conventional methods as long as a few conditions are met. As a result of this research, the cost of assessing human health risks can be cut in half, which represents a potential savings of many millions of dollars each year for contaminated land owners and developers. One of the samplers studied was the Waterloo membrane sampler, which is being commercialized through a partnership between the inventors and Serum Laboratories, a subsidiary of my employer, Geosyntec Consultants. To date, Serum has produced and sold over 3,000 samplers, and the rate of increase in product orders is growing exponentially. We have existing partnerships with commercial laboratories in the United States and Australia, and are in negotiations with laboratories in Europe and Asia, which covers most of the industrial world. The Waterloo membrane sampler has several advantages over other passive samplers. It's smaller, and the membrane eliminates negative bias from high humidity and positive bias from high wind speed. But the most interesting feature is that the calibration constants, or uptake rates, for a wide variety of chemicals can be predicted from the linear temperature programmed retention indices, as shown in this graph. This allows the sampler to be reasonably accurate even with chemicals for which it has not been specifically calibrated. During the conduct of the research, we also developed a mathematical model to customize the sampler to provide quantitative passive soil vapor concentration measurements. As a result, we now offer 2 varieties of the Waterloo membrane sampler. The smaller version is specifically designed for soil gas monitoring. This research will help me in my capacity as vapor intrusion practice leader at Geosyntec provide very cost-effective services to international clients, which is a business model that has helped our office double in size every 5 years since its inception. We employ the best and brightest graduates of Ontario universities and are developing several new technologies for contaminated land management. Research and development is the key to our success. Thank you for watching.